This is problem 7-104 from section 7.1.7. What central angle, measured in degrees, corresponds to a distance around the unit circle of 7 pi over 3? So we need to answer this question first before we move on to part A, B, and C. So what's central angle in degrees? So basically, what is 7 pi over 3 in degrees? So what we're going to start with is we know halfway across our circle is pi over here. And what we're going to do is break pi into 3 equal parts. So that's about there. And let's also do that on the bottom. So now I have 3 equal parts total. And the whole thing. And each of these is worth 60 degrees. Okay? So, or they would be called pi over 3 if we're in radians. So we're going to figure out how many of those, what degree gets me to 7 pi over 3's. So here's 1. Here's 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3. So I went all the way around once and back to here. So that angle measurement would be 360, because we went all the way around, plus the one measurement of what pi over 3 is, which is 60 degrees. So that's really going to be 420 degrees. Okay, so that's the part before we even get to the questions. 420 degrees is 7 pi over 3. What other angles will take you to the same point on the circle? Well, we want the same exact place, so depending on the number of cycles we go on. So in one cycle around, 60 degrees would be a good one, right? 420 is there. If I keep adding another cycle, so if I keep adding 360 degrees plus however many times I'm going around, we can find infinite number of angles. So we're going to use this in radians. So my 60 degrees was pi over 3 radians plus one time around the circle is going to be 2 pi radians. Or I could go in the negative direction. I could go backwards. Okay, it just wants you to do the same height. Doesn't matter. Is this the 4th time you've been going around the circle, or are you in backwards and going backwards around the circle? It just wants the same height. So this can get me to the same thing, but I want a little n here, or a little x, which represents the number of cycles. Okay, so if I'm going 5 cycles around, I would do 5 times 2 pi, and then add the pi over 3. That would get me to another corresponding angle. Okay. Part B asks to make a sketch of the unit circle showing the resulting right triangle. Well, I'm just going to do it up in this, draw the triangle in this unit circle that's already drawn in. And here's my triangle. Okay, and I know this is 60 degrees, this is 90, and this up here is going to be 30 degrees. It's 30, 60, 90 triangle. Okay, so that's part B. Find the sine of 7 pi over 3, cosine, and tangent of that angle every time. So basically it's going to be the same sine, cosine, and tangent of 60 degrees. It's just we went on the circle one more time around, but it's still going to be the same values because you're at the same point. So find the sine of 7 pi over 3. So let me talk about the relationship between the angles. Let me actually draw, I know it says to be inside the unit circle, but we're going to draw another triangle just so we can write some more stuff on here. So this is the 60 degrees, this is 90, this is across from 30, or this is 30 degrees. Okay, so if we talk about the old values that you learned from geometry class last year, the relationships between special right triangles, across from the 30 was a 1, across from the 60 was radical 3, and across from the 90 was a 2. Now I've had several people in class say, well, the radius isn't supposed to be 2, it's supposed to be 1. So if we change those by dividing everything by 2, now we have some better answers. So this is really worth 1. Okay? So if we use those values for the ratio, now you don't remember those because you didn't learn those, you learned the ones in the green. So if we change those to make them work, now with our radius always being 1, we know sine is always the height. Okay? So now I can just look at the height of this triangle, sine of pi over 3, or sine of 60, the height is right here, radical 3 over 2. That's the sine. Oh, sorry, this is 7 pi over 3. I forgot, because it's still the same thing. So it's really 7 pi over 3, but it's the same as sine of regular pi over 3. So let's find the cosine of 7 pi over 3. Cosine, again, is my horizontal distance, this distance from the center pole. Okay, so if I change my ratios so my radius is worth 1, now I can just look at the horizontal distance, which is 1/2. Right, we want these to be exact values. If we can use our 30, 60, 90 triangle or 45, 45, 90 triangle, we want to use exact values, which means fractions, square root signs, those are all good. Okay? The new part of this from today's lesson is the tangent of 7 pi over 3. Now, tangent is sine of 7 pi over 3 divided by the cosine. So we already found those. So all we need to do is take sine, which was radical 3 over 2, divided by cosine, which was 1/2. Okay? So we have a couple fractions inside of each other. So to get rid of that, I'm going to multiply by the reciprocal down here. So this will cancel out. Right? I need to do the same thing on the top of my fraction. So I have this 2 and that 2 are going to cancel out. So really the tangent of 7 pi over 3 is going to equal radical 3 over 1 or just radical 3. Okay? So the new part of today's lesson was tangent. Tangent is sine divided by the cosine. So you use those values you just found and divide them and simplify.